Hello, this is Mrs. Groves, and we're going to continue our discussions, Algebra 1 discussions, and solving systems algebraically. If you look at your assignment sheet, this is going to be your homework for tonight. These are the corrected dates due to the snowstorm. On my website, we'll have the current assignment sheet with corrected dates if there are any other snow days. You're going to have 3 assignments to do. 2 are from the book, and then there's going to be a worksheet with lots of word problems on it. So make sure that you know what your homework is. And so we're going to start with special cases. So take out, or you should be receiving this handout. These are notes. And the first part of special cases, these are special types of linear systems. I'm going to review the special cases when we did graphing, and then I'll go and discuss how you can determine if it's a special case when you're solving systems algebraically. So we have when we graph, we have 3 possible solutions. 1 solution, no solutions, infinite solutions. So here's an example of 1 solution. The solution is an ordered pair, which are xy coordinates. For 1 solution, the lines will intersect. The lines have different slopes. So if the lines have different slopes, they will intersect someplace. That's 1 solution. The next type is we have 2 lines. The lines are parallel. Notice the lines have the same slope and different y-intercepts. So here's a y-intercept for line 1, and here's the y-intercept for line 2. So in this case, we have parallel lines which will never intersect. Next, we have infinite solutions. The lines are the same. If you have 2 equations and they turn out to be identical, you're going to have 2 lines and they're going to sit on top of each other. The lines have the same slope and the same y-intercept. So it's important to know that this solution is not all real numbers. This solutions are all the points on the line. All the points, and there's an infinite number of points on this line. So that's a review of determining the 3 types of solutions. When you're graphing, now we're going to go to special cases, solving systems algebraically. And we're going to do examples with both the elimination and the substitution method. All right. So here is going to be an example of no solution. And I want you to solve this with the elimination method. You look at it and you can say that these have the same coefficients. So in order for me to solve this with the elimination method, I have to multiply one equation by -1. So I bring this equation over. I get -2x plus y equals 1. And then I take the -1, and I have my visitor Ozzy here with me, so he's enjoying a bone while I'm teaching. Multiply this by -1. See if you get the same answer as I do. So you should have gotten 2x minus y equals 3. Now we can add down. -2x and 2x cancels out. It's 0. X is eliminated. Y and -y, that's 0. So y is eliminated. 0 plus 0 is 0, equal to 1 plus 3 is 4. Notice this is false. So what's the solution? I bet you can guess. And this statement will help you understand this. The variables are eliminated. And you are left with a false statement. 0 is not equal to 4. This tells you the system has no solution. So the variables have dropped out. The numbers, which we call constants, are not equal. Therefore, this is an example of no solution. Now we're going to go to another example. Okay. And infinitely many solutions. Remember, you can use the symbol infinite solutions. You cannot say all real numbers. That is wrong. It's infinite solutions. So I want you to take this problem right here. I want you to rewrite it, and I want you to solve it with the elimination method. And I'm going to let you solve that. We have these two equations, and I want you to use the elimination method. All right. So the way that always works is you look at x, okay, and you're going to multiply it by the opposite coefficient. So basically, you multiply this equation by 3 and the bottom equation by 1. So you get 3x plus 9y equals -9. Now, we want to add down. So what I do is, I'm going to look at this, I'm going to say 3x, and I'm going to stop. I'm going to say to myself, if I add 3x and 3x, have I eliminated x? No. So I have to multiply it by -1. So I would get -3x, -1 times 9, minus 9y, -1 times -9, equals 9. Now some of you may have just said to yourself, why can't I just multiply the top equation by -3? And the answer is you can. Remember, the goal is to eliminate one variable. So if I multiply the top equation by -3, -3 and +3 is 0, it would be eliminated. All right. So those of you that are doing that, great job. You're on the right track. You're doing just what you should be. So these cancel out to be 0. These cancel out to be 0. And on the left-hand side, I get 0. -9 equals -9. That's 0. So in this case, I have a true. This is a true statement. The variables are eliminated. And you are left with a statement that is true. This is true. No variables, this is true. This tells you the system has infinite solutions. You can write it like that, or you can write infinite solutions. Okay. So those are two examples of the special cases using the elimination method. Now we have two more problems, and we're going to review the substitution method. And remember, with the substitution method, I have to have one equation isolated. And I'm going to take this and substitute it in for my y. So I have 4x minus 2 equals 14, and y is being replaced with 2x minus 7. And then I go and I solve it. So you're going to solve for x. You do it. I'll do it. Make sure we get the right answers. You should get 14 equals 14, and that's a true statement. So that means that this answer to this is infinite solutions. Okay. So now we're going to do the second one. We want to use the substitution method, but we have a little problem here. We have to isolate one of the variables. So I see that there's two choices. If I want to use the first equation, I'm going to divide everything by 2. Or I can look at the second equation and I can add 4x and add 4x, and I get y equals 4x plus 4. And then what I'm going to do is I'm going to take this 4x plus 4 and I'm going to substitute it in for y. So 2, y is 4x plus 4 equals 8x plus 4. I'm going to distribute 8x plus 4 equals 8x plus 4. I'm going to get the variables on the same side, so I'm going to subtract 8x from both sides. Oops, I made a little math here. Did you catch that? 2 times 4 is 8x. 2 times 4 is 8. So I'm left with 8 equals 4, which is false. Therefore, my answer is no solution. Okay, so that's using the substitution method. So I'd like you to write this down. Infinite solutions. Both variables drop out and the constants, the numbers, are equal. The variable drops out and the numbers are equal. The next one, no solution. Both variables drop out and the constants are not equal. 8 is not equal to 4. This is no solution. So you should put big stars next to these. So that's how you tell whether they're infinite solutions or no solutions. So that wraps up our lessons on solving systems algebraically with the substitution and elimination method, and then covering the special cases. We'll be going on to word problems. See you then. Signing off, Mrs. Groves.